I'm Jonathan, and this is Mapped Learning, a place to learn freely without ads or noise. Let's continue our journey. In this video, I'm going to be covering IPv4 subnetting, and this is part 2. In part 1, I covered the basics of subnetting, and I ended with showing how to AND IP addresses and subnet masks so that you could determine whether two IP addresses were on the same network or not. In this video, I will be teaching my quicker way on how to subnet in your head with a little bit of practice. And the most you need to know is addition, subtraction, maybe a tiny bit of multiplication and division, but it's not going to be extremely difficult. Now, if you haven't watched part 1 already, I strongly recommend you do that. On the left-hand side, I have a QR code for the Substack post with the part 1 video, and the QR code on the right has the YouTube video for part 1. So what am I going to cover in this video that makes subnetting easier? Well, to begin, I'm going to show the subnet mask table. This is where you write all of the things that you're going to need to memorize, or you would need to memorize, if you were working out subnetting on paper. Then I'm going to cover the magic number. Now, I can't take credit for calling it the magic number. I learned that back in the late 90s when I took the Cisco curriculum for CCNA, and my instructor back then taught us about the magic number. And then finally, if you're interested, at the very end of this video, I'm going to be doing some practice exercises with a bunch of different IP addresses and CIDR notations that are subnetted so you can see how this works. So this is the subnet mask table that you're going to want to write down every single time you're either going to be working with subnets, you're working on a certification exam, anything where this type of information will be useful. Now, if you are taking a certification exam, the testing facility usually lets you have 1 or 2 dry erase small pieces of paper that you can write on. And if your test has anything to do with networking, whether it's Microsoft or Cisco, Juniper, doesn't matter. Write these down in this way. On the far left-hand side, you're going to have the class ranges, A through E, and their subnet ranges from 0 to 255 on the right. Below, at the very bottom, you're going to have the binary scale that has 2 to the 0 power all the way to 2 to the 7. And remember my trick for remembering that. Start at 2 to the power of 2 equals 4. And then on the right-hand side, you're going to write the numbers 1 through 8, and you're going to write this scale of numbers based on how many bits are borrowed from the octet of interest. Now, what do I mean by the octet of interest? Well, let's pretend I have an IP address here, and we'll use a familiar one, 192.168.1.50. Okay? So, by default, what is the subnet mask for this network? Well, first we have to determine what class it is. So we look at the very first octet and the first octet only. And since it's 192, we can see that it is a class C. Okay. So what is the default subnet mask for class C? Well, do you remember what the CIDR notation is? If you said 24, you're right. So we put /24. Okay, and that means that the default subnet mask for this IP address is 255.255.255.0. I should have probably picked a class A, but never mind. Now, that is if if we're using a default subnet mask. But instead of using 24, we're going to use 28. Okay? So by default, 8 plus 8 plus 8 is 24. And if we are borrowing 4 more bits, what is the new subnet mask? Well, remember what I said before. When you're subnetting, it's always from left to right with binary. So the octet of interest in this case is the last octet, because that is the octet where we are borrowing bits into. Okay? So if we're borrowing 4 bits, down here at the binary scale, we have 1, 2, 3, 4. Okay? Now this is where these numbers on the right come in. If you take 128 plus 64, that is 192. Add 32, it's 224. Add 16, that is 240. So what does that mean for our new subnet mask? That means that our new subnet mask is 255.255.255.240. And that's it. That is literally all you have to remember. When you borrow 1 bit, it's 128, okay, for the new subnet mask. If you borrow 2 bits, 192, all the way to the 8, which is 255, and then you're just borrowing the entire octet. So that is exactly how you figure out these numbers. Now, the magic number. Before I get to what the magic number does, I'm going to tell you what the magic number is. I'm going to tell you that by telling you how to calculate it, air quotes, calculate. So there's 2 different ways to calculate the magic number. The first one is you take 256 and you subtract the new subnet mask in the octet of interest. Okay, let's go to the previous slide and look at that. 240. Okay, so the new subnet mask is 240. And we're going to subtract that. Okay, so 6, 1, 0, 16. Okay, that is our magic number. Okay, so just keep that in mind. If we say we did 248, okay, then the magic number would be 256 minus 248, and the magic number would be 8. But in this case, the magic number is 16, and that will get me into the second way to calculate the magic number. And this isn't even a calculation. You take a look at the binary scale at the bottom and write down the new subnet mask in the octet of interest in binary starting at the left. So 1, 2, 3, 4. The last bit turned on points to the magic number. Okay? Now that is what the magic number is. What do we do with it? And this is the key. Okay? So we're going to use the same example before. 192.168.1.50/28. Okay? I'm just going to keep it the same. In the IP address, all octets to the left of the octet of interest stay the same. Okay? Now, what is the octet of interest in this IP address? Well, since the CIDR notation is 28, we have 8 plus 8 plus 8 plus 4. Okay, so this is our octet of interest. All of these bits are turned on in the subnet mask. Okay, 255.255.255.240. Okay, so everything to the left of the octet of interest stays the same as far as IP addresses go. Okay, so every single IP address in this range of subnets. Okay, so we have 192.168.1 dot something. Don't know yet. But everything that we're working with in the octet of interest, 192.168.1, is the overall network. Okay? Remember at the very beginning of IPv4, I said that subnet could mean two different things. It could mean a smaller network coming from a larger network, or the larger network in whole. In this case, we are using subnet to talk about both, but semantics, it doesn't really matter. So we started with 192.168.1.0 is a class C. By default, it's /24, and that is the network. Okay. But if we're subnetting and we're borrowing bits into the last octet, then we have a bunch of sub networks that belong to this larger network. Okay. And that will become clear if you stick around for the exercises. Number 2, in the IP address, the octet of interest and any to the right becomes 0. Okay. So our octet of interest in this example is the last octet. So that starts at 0. Okay, and anything to the right, but we don't have anything to the right, so it's just the octet at the end for now. Excuse me. 3. The resulting IP address after the previous two steps become the first subnetted network or first network ID. So this right here is the network ID. Okay, the first subnet. Every network has a network ID, and this address with the 1.0 is the first network in that series of networks. Now, we know what the magic number is, we know how to calculate it, and we know how to use it in an IP address. Well, what does it do for you when you're subnetting? Why do they call it the magic number? All right, so we're going to start. I'm just going to work at the octet of interest that from the previous example. So it's going to be .0 here. Okay, so just stick with me on this. Number 1, starting at 0 in the octet of interest, adding the magic number each time tells you where the next network starts. Okay, let me emphasize that in all exclamation points. Adding the magic number starting at 0 each time tells you where the next network starts. Okay? So we will just go with that for now. And if I take the magic number, which in this case is 16, okay, right here, 16, and I add it to 0, well, obviously, that is 16. I add it again. Okay, 16 plus 16, 32. I add it again, 48. How far does it go? Well, it goes as far as to when you get to the last number, which ironically is going to be the new subnet mask in the octet of interest, 240. Why? Because if you add the magic number to 240, what does it get you? 256. That's too large for a single octet. So when you reach the new subnet mask in the octet of interest, you don't need to add the magic number anymore. Okay? Now, I'm going to just work with the very first octet, or I'm going to work with the first network for this example again. So we're going to be .0. So 192.168.1.0. Okay? Number 2. Starting at 0 in the octet of interest, add one binary bit to get the first host address. Okay, so 1 added to 0, and when we add bits, we are starting at the far right. Okay, we only start at the far left if we're working on subnetting. In this case, we are looking at host addresses, so we start at the right and move left. So if I add one binary bit to 0, it's 1. Okay. If I were to add one binary bit, well, one binary bit plus one binary bit is 1, 0. Okay. 1, 0. That would be 2. And so on and so forth. 3, 4, 5, all the way up to 255. Okay. So these are all host addresses. Remember, this is the network ID. This is the first host address. And it just keeps going, keeps going, keeps going. Number 3, subtract one binary bit from the next network to get the broadcast address of this network. So remember what the next network was? We take the magic number of 16 and add it to 0. So it's .16. We subtract one binary bit from 16. What does that give us? 15. Okay? .15. That is the broadcast address. And in another video, I will explain all different types of network communication. But broadcast means sending communications to all hosts in that subnet. So that's the broadcast address. Number 4, subtract one binary bit from the broadcast, and that will give you the last host address. So if we subtract 1 from 15, we get 14. Okay, that looks like a 9, but I swear it's a 4. This is the last host in this subnet. Okay, so the network ID is 192.168.1.0. The available host range for this subnet is 192.168.1.1 through 14. .15 is the broadcast, and .16 is the next network. And you just follow the calculations each time. If I add one binary bit to this network ID, that gives me .17. And what is that for this network? Well, that's the first available host address. Remember the 32? That's our next network after this one. If I subtract one binary bit, that gives me 31. What is that? That is the broadcast address for the 16 net. And finally, if I subtract one binary bit from 31, I get .30. And what is that? That is the last available host for this particular network, subnet. So the network is 192.168.1.16/28. The first available host is .15 or .17, apologies. The next network is .32. The broadcast address is 31. The available host range is 17 through 30. That is literally what subnetting is. And like I said before, we're going to see 9 different examples, 3 from each class, when we do the exercises. So that is exactly how I subnet using my method that requires very little calculations. A lot of addition, a lot of subtraction, a little bit of multiplication and division if you're looking for networks, but that is how I do it. Now, I will have a part 3 for this subnetting series, and in the next part, I will cover VLSM, what the acronym is and what it means. I'm going to show you how to use VLSM to design efficient subnets. And we're going to do more practice exercises, but these exercises are going to be based on real world and certification exam word problems. Thank you for being here. If this helped you, share it with someone who's learning too. Everything I make is free, and if you want to support the mission, the links are below. If you want to pause here and digest, feel free. But if you want to stick around, we're going to walk through those 9 subnetting exercises together, 3 from each class. I'll see you in the next one. If you've made it this far, congratulations. I'm going to warn you, from this part to the end, it may be a bit long, but that's because I'm going to cover all 9 subnetting exercises. So without any further ado, let's get started. So I have my cheat sheet, if you remember from the beginning slides. I have written them down here, but I added some space. So up here I have, top left, I have the class range with the octet ranges. Below that, remember what every network has. It has a network ID, first host, last host, broadcast address, and next network. When I was teaching subnetting, this is what I would ask my students to give me if I gave them a subnetting exercise. And if they could do it all in their head in front of me, then I would give them extra credit. And this, we're going to start slow. I'm going to walk you through it step by step, but each time I'm going to get a little bit faster. And that is how people subnet in their heads. On the top right, I have the octet of interest table with the number of bits borrowed and what the new subnet mask is in the octet of interest. Below that, I have 9 example IP addresses. And how did I get that? Well, if you just go to any website that does subnetting, I think there's Subnet Calculator and other subnet calculators. You just give it the class and tell it, give me X number of IP addresses, and it'll give it to you at random. So I do have 3 subnetted networks in each class for a total of 9. And then at the bottom, I have the binary scale, which helps for addition. So let's get started. The first IP address is 10.24.5.200/12. Okay. So, first of all, what class is this? Well, remember, we only look at the first octet right here. So it is a class A because the range is from 0 to 127 and it's a 10. Okay. What is the default subnet mask for a class A network? It is 255.0.0.0. Okay. So that would be a /8 for class A. But here we have we have a CIDR notation of 12. So here is 8 bits, and here would be another 8 bits, but 12 minus 8 is 4. So we are borrowing 4 bits into the next octet. Okay? So this right here, off the bat, is our octet of interest, because this is where we are subnetting into. And for now, we can forget everything else. Okay? So now we need the new subnet mask. Okay? Well, we know that it's 255 dot something. Okay? Well, if I borrow 4 bits, 1, 2, 3, 4, we did this exercise before. Right here is 240. Okay? And in a subnet mask, once the last bit is turned on, everything to the right is a 0. So that is our new subnet mask. Okay? 255.240.0.0. Okay? Well, now I got what I need. What's the next step? And if you haven't done this many times, this is the spot where most people forget where to go. Okay, I got the basics, but I don't remember what to do from here. Okay, well, that is where the magic number comes in. What we have now is enough information to get the magic number. Okay, for this example, what is the magic number? And not including the previous exercise. So the first way to get the magic number is take 256 minus the new subnet mask in the octet of interest, which is 240. The second way is to get the last binary bit that's turned on in the octet of interest. So it is 16 right here. Okay? So what's the next step after this? Okay? Well, we know what the octet of interest is now. And remember the rule. The first one is everything to the left of the octet of interest stays the same when we're talking about the IP address. So here, the octet of interest is the second octet. So the only one to the left of it is 10. Okay, so 10. The second rule, the octet of interest, and every octet to the right is 0. 0.0.0. Okay? /12. Okay? And remember, this is the very first subnet. Very first subnet in the 10 network. Okay? If we were using this subnet mask for every single address in this organization. Okay? Now, I'm going to give you the first networks for this network, and then we're going to go from there. So, right now, the network ID for this first subnet is this 10.0.0.0. How do we get the first available host? We add 1 binary bit. And when I say one binary bit, it's one binary bit all the way to the right. All the way to the right. Not in the octet of interest, but when we're talking about hosts, it's all the way to the right. So that's 10.0.0.1. That is the first available host. Okay. What is the last host? What's the broadcast address? Well, it's easier just to get the next network. So remember how we get the next network. Add the magic number to the octet of interest. Okay? And this is where it also gets confusing. When we're talking about hosts, we start at the right. When we talk about subnets, we talk about the octet of interest. Okay? So if you were going to take this 16 magic number and add it to 1, that's not correct. Okay? We're going to add it to the octet of interest. Okay? So it's 10.16.0.0. Sorry. Okay? So that's the next network. 10.16.0.0 is this network, okay, this new network, subtract one binary bit, okay, from the host. If we subtract one binary bit, what does that give us? Well, 1 less than 0 when we're talking about octets makes it 255, okay? Just like if you were subtracting 1 from 10, you can't take 0 from 1, so you borrow from the left. And carry over. Okay? To the left, 0 becomes 255. Can we subtract 1 bit from 16? Yes. 15. Okay? And 10 is the same. So this is the broadcast address for this network, the /12. 10.15.255.255. So that means that, let me go ahead and erase all this. We have 10.0.0.0/12, okay, is the very first network in this whole range. The first host address in this network is .1. The next network is 10.16. Okay, that's the next network. Subtract one binary bit, and remember it's 10.15.255.255. That's the broadcast for this network. Subtract 1, it's 10.15.255.254. So, on the left-hand side at the bottom, if I were asking you this on an exam for this first network, you would put 10.0.0.0. First host is 10.0.0.1. The last host is 10.15.255.255. I apologize. I got ahead of myself there. If you were yelling at me, yes, 254 is the last host, but that's because we already got it. But we would go from the first host to the next network, which is 10.16.0.0. And the broadcast is 10.15.255.255. Okay. And if you were to write all that down, you would be correct for this particular network. But that's not what I asked, right? What I asked is for this IP address. Okay, 10.24.5.200. Okay, I want to know what the network ID, first, last broadcast, and next network is for this IP address with the /12. Okay, that's harder. Okay, so how do we do that? Okay, we got the first subnet, now we want this one. Okay, well, remember the magic number. If we start from 0 in the octet of interest, that tells us what the next network is when we add the magic number. So we have 0, 16. Is 16 larger than 24? No. Add 16 again, we get 32. Okay. Is 32 larger than 24? Yes. So what does that mean? Well, remember, the magic number tells us where the next network starts. Okay. So 24 does not belong to the 32 network. It belongs to the 16 network. Okay. So now we have our next network, 10.16.0.0. Remember, octet of interest, everything to the left stays the same. Everything to the right turns to 0. Okay? We don't do that with the magic number octet because we already did. We added it to 0. So now, what is our first host? So network ID is 10.16.0.0. Okay? First host, we add one binary bit, 10.16.0.1. 10.16.0.1. Okay? What's the next network? Well, we already got that before. That is 10.32.0.0. Subtract one binary bit from the next network, and that gives us the broadcast. Everywhere where there's a 0 at the end, it turns into 255, and then we can subtract from the octet of interest. So then the broadcast is 10.31.255.255. And then the last host is 10.31.255.254. Okay? That is for this IP address, 10.24.5.200, because it is somewhere in between here. And that's it for this IP address. Next is 23.150.90.14/20. Okay. This again is a class A. So by default, it's 255.0.0.0, but we're at 20. Okay. So what is our octet of interest now? So we take 8 plus 8, that's 16. So 20 minus 16 is 4. Okay. Now the third octet is our octet of interest. So everything to the left of that stays the same. 23.150. Okay. Take the octet of interest and everything to the right becomes a 0. That is the first network. Nope. Yes. Yes. I almost got ahead of myself there. I, I, I am doing it right. See, sometimes it confuses me too. So this is the first network in this whole subnetted network, 23.150.0.0, okay? Because the third octet is the octet of interest, okay? Now, we take the magic number and we add it to the octet of interest, okay? So what's the magic number? Well, in this third octet, we're borrowing 4 bits, okay? Right here. Same as before, same as the last exercise. So the new subnet mask is 255.255.240.0. Okay? Now, without calculating all this stuff, let's just jump right in, getting to this network right here. Okay? 23.150.90.14. We need to know everything about that network. Okay? So, what we're going to do is we're going to take 16, add it to 0 until we get a number that is either 90 or 1 over. So this is where the division and uh, addition comes in handy. So 16, 32, 48, take 48 plus 16, that's 64. Okay. And then let's see, 16, that's 80. And then 96. Okay. So 90 is between 80 and 96. Okay. So that means that the network ID for this subnetted network is 23.150.80.0. 80.0. First host, add 1 binary bit, 80.1. The next network is 96. Okay. 23.150.96.0. The broadcast for this network, remember, where there's a 0, it turns into 255. So 23.150.95.255. And then for the last host, 23.150.95.254. Okay? Considerably faster than the first one. That's literally it. Let's move on to the next one. 55.200.10.99/14. Okay, so first thing we do, it's a class A, and we're going 14. So 8 plus 6, okay, is 14. So now our new subnet mask is 255.123.456 or 252. 252.0.0. Okay? Magic number is what? 256 minus 252, or right here, 4. Magic number is 4. So in this case, this is going to be a lot easier because we know that 4 goes into 200 evenly. So that means that our network ID for this IP address is 55.200.0.0. First host, 55.200.0.1. Next network, well, we add the magic number to the subnet, the octet of interest. Okay, remember what I said before. If we add the magic number to the, oh, I got, forget the last 5 seconds that I talked about. Haha. 200. I looked at the subnet mask and threw off my memory. So 4 added to 200 is 204. 55.204.0.0. Subtract one binary bit. Broadcast is 55.203.255.255. And then last host 55.203.255.254. And there we go. Next one, 150.120.45.200/19. Okay, how many bits are we borrowing? 8, 16, 3 bits in the third octet. So 3 bits, 255.255.224.0 is our new subnet mask. Okay, magic number is 32. So the first network, whoops, let's try that again. 150.120. And if the magic number is 32, it's 32, then 64. So 32 and 64, 45 is between that. So this is the 32 network. Whoops. 150.120.32.1. Add 32. Next network, 150.120.64.0. Broadcast 150.120.63.255. 150.120.63.254. All right, 172.22.199.14/22. 8, 16, 24. So 6 into here. 6 is 252. So 255.252.0. Magic number is 4 again. Okay, remember 200 was 4 evenly, so subtract 4 from 200 and we get 196. So 172.22.196.0, 172.22.196.1. Next network is 172.22.200.0, 172.22.199.255, and 172.22.199.254. Okay, we're getting there. 191.44.10.250/30. Okay, 8, 16, 24. Okay, it's 6 into the last octet. So again, 255.255.255.252. Again, magic number 4. 4 goes into 250. Nope, not quite. So if we take 256 and subtract 4, we get 252. Subtract 4 from that, we get 248. So don't be confused by that being an even number. The network is going to be 248. So 191.44.10.248. Oops, that's an 8. 191.44.10.249. Okay, next network. Well, take 248 and add 4. 191.44.10.252. 191.44.10.251 and 191.44.10.250. Now look at that, all in a row. 248, 249, 250, 251, 252. Perfect. 192.168.1.77/27. Okay, 8, 16, 24, 3 bits there, magic number 32. So 0, 32, 64, 96. So it's between 64 and 96. 192.168.1.64. Yep. 192.168.1.65. 192.168.1.96. 192.168.1.95 and 192.168.1.94. Okay, see how much faster this is going? 203.44.199.200/29. So 8, 16, 24, 5 into the last octet. 5 is 248. So 255.255.255.248. Okay, 5. Magic number is 8. 8 goes into 200 how many times? Well, I am pretty bad. I am actually gonna cheat right now. 200 divided by 8, that's 25. So 8 times 26 is 208. So it is 200. Haha. 203.44.199.200. 203.44.199.201. 203.44.199, 208, 203.44.199, 207, 203.44.199, 206. One more. We're almost there. 223, 10, 55, 14, 26, 8, 16, 24, 2 into the last octet, 64. So last octet is between 0 and 64. 223.10.55 dot, and this happens to be part of the 0 network. 223.10.55 0. 223.10.55 1. 223.10.55 64. 223.10.55 63. 223.10.55 62. And if you have made it all this way to this point, congratulations. You have seen how quickly you can subnet now. And in another video, I will explain exactly why this is not only helpful but mandatory if you are going to be taking a network certification exam or if you're going to be working on creating networks in your career. Thank you for watching, and I'll see you in the next